for this group will be Aomawa Shields. She's a PhD student pursuing her degree at the University of Washington.
Thanks, John. Good morning, everybody.
Good morning.
I am a fourth-year PhD candidate now at the University of Washington in astronomy and astrobiology.
Louder.
So phase one for me was revolutionary. I had felt so alone and isolated for so long, and suddenly not only did I have a program mentor who embodied so much of what I want in my career, but I also was now part of a community of scientists of color. And throughout the year, I've stayed in touch with my program mentor, my cohort, and the entire program, and have received tremendous support. So some of the goals that came out, my short-term goals during phase one included, I wanted to pass my general exam. I knew I was going to be taking that sometime during the following year. I planned to apply to the astronaut candidate program. I wanted to compete in a science communication competition called VIII Lab, and I was concerned about having done enough research to have a poster at the Astrobiology Science Conference that was going to happen the following April. With the guidance and support of my mentor, I have accomplished all of my short-term goals and am well on my way towards achieving my medium-range goals, one of which is finishing my PhD in the next 1.5 to 2 years. And towards that end, I have received my master's degree in astronomy last year, and I submitted my first author paper for publication in the journal Astrobiology. And I completed all of the required coursework and workshops for the astrobiology dual title PhD. So when I finally get my PhD, it will say in astronomy and astrobiology. Here are some photos from the highlights of the previous year. So I was able to compete in the VIII Lab Science Communication Competition, and I actually won the Audience Choice Award, which was a real thrill. And that's me getting the award from Nichelle Nichols, Lieutenant Uhura from the original Star Trek series. And that was awesome. This is at the far end, my advisor, Victoria Meadows, and I at the graduation ceremony where I received my master's degree. Along the way, my husband and I celebrated our 8th wedding anniversary. And that's me studying for my general exam with my cat Mimi helping me read papers. So I passed the general exam at the end of November, middle of November last year, and am now officially a PhD candidate. I also attended a lot of conferences last year, including my phase 2 experience preparing for an academic career in the geosciences, and that was wonderful. It gave me a great impression of what becoming an academic professor would be like at different institutions. I also presented my work in oral presentations for the first time at conferences, 2 conferences, the Astrobiology Graduate Student Conference and the American Astronomical Society Winter Meeting. In fact, I had done so much last year that the UW Astrobiology program chose to feature me in a student spotlight. So this concern I had about having done enough research to have a poster at AbSciCon, the Astrobiology Science Conference, I did, and that poster ended up winning first place in the student poster competition. And this is me getting the award from the heads of the NASA Astrobiology Institute. So that poster was sort of the beginnings of the research that I then went on to explore and evolve into a paper. And it's looking at how planets around other stars might experience similar climate extremes to what our Earth is believed to have experienced hundreds of millions of years ago, where the Earth was totally ice-covered. So I'm interested in finding out if that could happen on other planets orbiting other stars, and how ice coverage is affected by the star interacting with the planet and the planet itself being in different orientations. This is a plot from the paper that I submitted for publication. So at the top you have the amount of light that stars of different types emit at different wavelengths. And at the bottom you have the reflectivity of ice at different wavelengths. In the short wavelengths, you can see that ice is very reflective. But at long wavelengths, where these cool red stars emit strongly, ice becomes extremely absorptive. So ice could absorb that light instead of reflect it and actually melt the ice. So what we're seeing, I'll wrap up, is that this is here how much light you get from the star and how far the ice goes down. It's a lot harder to have a completely ice-covered planet if the planet is around a red star. You have to reduce the light by a lot more. And so we're seeing that it's harder to freeze planets around cool stars. And I mentioned at phase 1 that I wanted to go to Bora Bora when I get my PhD. I've started saving for Bora Bora. So I'm on my way. I'm just so grateful for MS PhDs and the other funding sources for supporting this research. And I got to meet LeVar Burton. So thank you.